The role of the PLC's input-output I/O system is to translate the signals received from input devices into low-voltage DC signals that the CPU can use, and to perform the reverse operation when the CPU sends signals to output devices. In addition, the I/O system protects internal circuits from harmful voltage and current variations. A small PLC may have some or all of its I/O channels in the same housing with the CPU. For example, the accompanying graphic shows a CPU 1211C with 6 onboard connections for inputs and 4 onboard connections for outputs. This S7-1200 CPU model also permits a small signal board to be added internally for some I/O expansion, but does not permit the addition of external signal modules. Most Siemens PLCs, however, including the ones shown in the accompanying graphic, allow signal modules to be added. Some or all of these modules may be close to the CPU, but signal modules can also be remote from the CPU. In addition, for larger complex applications, the number and types of signal modules is typically greater because the number and types of I/O devices required are greater. Examples of input devices used with digital signal modules are push buttons, limit switches, temperature switches, pressure switches, level switches, flow switches, photoelectric switches, and proximity switches. Some input devices use direct current DC, and other input devices use alternating current AC. The specifications for each device type also identify the level of voltage and current required by the device. An additional consideration when matching a digital input signal module to a DC input device is the polarity of current flow. Some DC devices are electromechanical, so the polarity of current flow does not matter. But other devices have built-in electronics that require a specific polarity of connection. For example, consider the S7-1200 PLC signal module shown in the accompanying graphic. This signal module is designed to work with 24 volts DC inputs and has connections for 8 DC input channels, 4 on top and 4 on the bottom. The accompanying graphic, for simplicity, shows only the top connections for this signal module. Note that this module allows the load power supply, which powers the input devices and circuits, to be connected with either polarity. The connection diagram shown on the left has sinking connections, and the connection diagram on the right has sourcing connections. The terms sinking and sourcing are designed to identify the direction of current flow, but because these terms are confusing, it's best to follow connection diagrams provided with the PLC documentation. Examples of output devices used with digital signal modules are lights, relays, solenoids, motor starters, valves, and heating elements. Some output devices use DC and other output devices use AC. 3 categories of digital output signal modules are AC modules, DC modules, and relay modules. AC output signal modules typically operate with a load power supply of 120 or 230 volts AC, or may be capable of operating with either source. These modules use a solid-state switching device, usually a triac, to control each output. This type of output works reliably with many AC output devices, but because a triac allows a small leakage current to flow when the output is off, it is not suitable for some AC devices. The accompanying graphic shows a DC output signal module designed to work with 24 volts DC outputs. This signal module has connections for 8 DC output channels, 4 on top and 4 on the bottom. And it is important to observe proper power supply polarity when making connections. The connection diagram shows the correct connections for the top terminals of the module. You may see the term source and sink as it relates to DC output signal modules, but because these terms can be confusing, it is best to refer to the connection diagrams. Relay output signal modules offer the advantage of being able to work with either AC or DC devices as long as the devices operate within the module specifications and the switching speed required is not too fast. Each output on a relay output module is a set of relay contacts that close when the output turns on and open when the output turns off. The accompanying graphic shows a relay output signal module with 8 output channels, 3 on top and 5 on the bottom. The connection diagram is for the top connections on the module. The markings above and below the load power supply symbol identify the connections required. For a single-phase AC supply, L stands for line and N stands for neutral. The plus and minus connections apply if a DC supply is used. An analog input signal is generated by a sensor that provides voltage or current that can vary within a range, such as 0 to 10 volts or 4 to 20 milliamps. An analog input signal module converts the current or voltage to a binary value that the CPU stores for use in the user program. The number of bits in the binary value is referred to as the channel resolution. The more bits, the greater number of values that can be represented. The resolution available depends upon the module. For example, the accompanying graphic shows a signal module with a channel resolution of either 13 bits or 16 bits, depending upon the module version. Temperature measurement is an example of an application that requires special signal processing. Two types of sensors commonly used to measure temperature are thermocouples and resistance temperature detectors, RTDs. A thermocouple is a temperature sensor made from two dissimilar metals joined at a point called a junction. A thermocouple produces a small voltage that is temperature dependent. An RTD, also called a resistance thermometer, is a temperature sensor made from a metal such as platinum, nickel, or copper that varies in resistance in a predictable manner as temperature varies. There are various types of thermocouples and RTDs, and each type has different characteristics that determine its application range. Because thermocouple and RTD signals are different and require special processing, some Siemens PLCs have thermocouple and RTD signal modules. However, the S7-1500 PLC analog input signal module shown in the accompanying graphic can be used with a variety of analog signals, including RTD and thermocouple signals. When the CPU sends a numerical value to an analog output channel, the analog module converts the value to a voltage or current within the range set up for the output channel. The channel is typically connected to an analog output device that is controlling something in a machine or process, such as motor speed, valve position, or temperature. PLC analog output signal modules vary in the number of output channels, channel resolution, and output signal types. The module shown in the accompanying graphic has two analog output channels. These channels can be set up for either the -10 to +10 volts range or the 0 to 20 milliamps range. The output resolution is 14 bits for the voltage range and 13 bits for the current range. Signal modules have LED status indicators that are useful for system installation and troubleshooting. For example, the accompanying graphic shows two S7-1200 signal modules, a combination digital input-output signal module and a combination analog input-output signal module. Both modules have a status LED for each channel. The digital channel status LED is green and turns on when the input or output is on. The analog channel LED is green when the channel has been configured and is active, and red when there is a channel error. Both modules have a diagnostic LED that is green when the module is operational and red when the module is defective or non-operational. Multiple system power supply types are typically available for a PLC model to match the system voltage. System power supplies also specify a power budget, which is the available power that a supply can provide to interconnected modules. A load power supply provides power to input and output devices and channel circuits. In some cases, the load power supply also provides power to other PLC modules, including a system power supply module. Because input and output devices vary considerably in terms of their current, voltage, and power requirements, load power supplies come in a variety of types and capabilities. For example, the accompanying graphic shows a load power supply module for an S7-1500 PLC that mounts on the mounting rail with other modules. Siemens also manufactures a range of C-top power supplies for use with many types of equipment, including PLCs. A PLC I/O system can include components mounted near a CPU and components dispersed throughout a facility. PLC I/O system components mounted remote from the CPU are referred to as distributed I/O. Many Siemens PLC models are designed to use SIMATIC ET200 distributed I/O systems with network connections. These systems include some components designed for control cabinet mounting and other components designed for use without control cabinets. ET200 systems include ET200S is a multifunctional, highly modular I/O system. Interface modules with a Profinet or Profibus connection and with or without an integrated CPU are available. ET200MP is a scalable I/O system used both as centralized I/O and in distributed configurations with Profinet. ET200SP is a scalable and highly flexible distributed I/O system with a Profinet interface module. The version of this system designed for areas subject to explosion hazards is ET200ISP. ET200M is a modular I/O station for the control cabinet and high-density I/O channel applications. Interface modules are available for Profibus and Profinet. ET200 Pro is an especially small, extremely rugged, and high-performance I/O system. Interface modules are available for Profibus and Profinet. An ET200 Pro IWLAN version is available for wireless connection to a Profinet I/O controller. Interface modules are also available with CPU functionality. ET200 Eco is a compact block I/O for cabinet-free installation directly on the machine, and it connects via Profibus. ET200 Eco PN is a compact block I/O for cabinet-free installation directly on the machine, and it connects via Profinet. For Siemens SIMATIC PLCs, configuration and parameter assignment is accomplished using Step 7 engineering software, which was originally developed before TIA Portal and is now also available in TIA Portal. Step 7 Professional TIA Portal works with most modular SIMATIC S7 PLCs. S7 1200 PLCs can also use Step 7 Basic TIA Portal. Part of this configuration involves assigning unique identifiers to system components. There are various types of identifiers needed for different uses. For example, device addresses identify programmable modules with interfaces to a network. A type of addressing that is critical for signal modules is I/O addressing. I/O addresses are assigned automatically when signal modules are added in Step 7 and can be changed later if needed. The addresses of a digital signal module's inputs I or outputs Q are assigned in groups of 8, even if the module does not use all 8 channels. This gives every channel on a digital signal module a unique address that identifies the bits in the CPU's process image that store the channel statuses. For example, the digital input signal module shown in the accompanying graphic has 32 input channels. This graphic also shows the input address assignments for each channel if the module is configured as described. Because an analog signal module has a resolution of up to 16 bits, 16 bits are required in the CPU's process image to store an analog input or output channel value. As an analog signal module is added in Step 7, I/O channels are automatically assigned addresses. The first channel on the module is assigned the starting address, and the last channel on the module is assigned the ending address. For example, if an S7-1500 8-channel analog input signal module is assigned input byte 256 as the starting address, the channels will use the input bytes shown in the accompanying graphic. Step 7 allows the use of symbolic names referred to as tags associated with memory addresses. PLC tags are stored in the CPU's PLC tag table. Tag names can contain letters, numbers, and some special characters, and each tag name must be unique for a CPU. Use of tags helps when debugging a program or troubleshooting a system. The accompanying graphic shows an example of a PLC program network with the following tags assigned: Start 1, Stop 1, and Motor 1. Tags are shown in quotation marks in the Step 7 TIA Portal program editor. Instruction operands can also be displayed. Absolute operands such as I1.0, I1.1, and Q3.0 in the accompanying graphic are preceded by %. Absolute operands are available for use in any program block. Operands preceded by # are assigned to a specific program block. Step 7 TIA Portal software provides a variety of ways to monitor system operation if the programming device is connected to a CPU. This is useful for debugging a program or troubleshooting a system. For example, the accompanying graphic shows how a program network appears while being monitored in the Step 7 TIA Portal program editor with the push buttons in their normal state and the motor stopped. Note that the Start 1 and Motor 1 normally open contact instructions are shown in blue to indicate that they are open. The Motor 1 output coil instruction is also shown in blue to indicate that it is off. Next, the accompanying graphic shows how that program network appears in the Step 7 TIA Portal program editor while the Start push button is being pressed. Note that the 3 normally open contact instructions are shown in green to indicate that they are closed, and the Motor 1 output coil instruction is also shown in green to indicate that it is on. Finally, the accompanying graphic shows how that program network appears in the Step 7 TIA Portal program editor after the Start push button is released. Note that the Start 1 normally open contact instruction is once again shown in blue to indicate that it is open.